looking at some congruence via rigid motion problems. Here's some basic ones. They actually show the transformations for you, but it says use the drop-down menus below to state the sequence of transformation that maps figure S onto figure T in the animation below. Then use those transformations to determine are the figures congruent. Use the drop-down menus to explain why or why not. So again, just quickly, the idea here is that rigid motions keep things congruent, right? So if you are a rigid motion, I think it's because of the animation. So rigid motions. Geez, oh, Pete's so slow. Sorry about this. So I'm going to use abbreviation just because of the lag. So translation, reflections, or rotations. If that is all you use to map one figure to the next, then they will be congruent. But if you had to use a dilation at all, dilations create similarity. They're not rigid motions, so that'd be a no deal, not congruent, okay? So be aware of that. So again, rigid motions are there, dilations create similarity. All right, so if we take a look at this problem here, so if I scroll down, so S onto T, so it looks like I'm doing a reflection across the x-axis, which is this first one, and then a translation up onto T. So reflection and translation are both rigid motions. So we are doing a reflection across the x-axis, followed by a translation up. How many? Up 1, 2, 3. And what that does is it creates two figures that are congruent because we used only rigid motions. Submit my answer. And there we go. Okay. Now let's do an example of one that's not, right? All right, so let's take a look at this problem. So now we have figure Q going on to R. So figure Q is this blue figure. So notice what's happening here. So the blue figure is getting blown up. It's getting enlarged. And then it's rotating, or it's turning one quadrant. So to me, that's going to be a dilation and a rotation. Now, right when I say the word dilation, you should be thinking not congruent. So we do a dilation first. Now, what's the scale factor? Well, to find the scale factor, we're going to have to count this vertical side. See this side right here? It goes up 1, 2, 3. That's a distance of 3. What does its corresponding side length become after the enlargement? 1, 2, 3, 4, 5, 6. Right? So to find that scale factor, take the new length, divide by the old length, and you have a scale factor of 2. And then after it gets that, then it gets rotated. And the rotation is going one quadrant this way. From the second to third quadrant, that's a 90-degree rotation, and that is counterclockwise. 90 degrees counterclockwise rotation. Okay, let me erase my markings here so we can then finish this up. So again, once you see the word dilation, those two figures are not congruent because we did not only use rigid, we used some non-rigid motions. Submit that, and there we go. All right, next problem coming. All right, so the next one says determine a series of transformations that would map figure P onto Q, and it says press try to try out the transformation. So awesome. So this is like that one before. Now, the only bad part is they don't give us corresponding vertices, so I got to kind of make some up. So I think that this, I'm going to call that point A. So I think this top point would be point A prime. Let's call this point B, and this point corresponding would be B prime. So how are we getting from A to A prime and B to B prime? Well, it looks like this thing is being flipped, and it looks like it's being flipped this way, which means it's going across the y-axis. So I think that that's going to involve a reflection across the y-axis. So let's take a look. So if I choose reflect across the y-axis, and let's try it out. Right, so bingo, I think I'm in business because look what happened to A, right? A came here, now it's here. B came here, now it's here. So they're oriented, right, to line up with their A prime and B prime. So now the question is, how do I slide to get from A to A prime? Well, it looks like to go up 3. To get from B to B prime, I have to go up 3. So to me, now it's going to be followed by a translation up 3. Followed by a translation, we're going to go up 3 units. Let's try it out. So there's my reflection. There's my translation up 3. Awesome. Boom. And now you have to finish that same question. Are the two figures congruent? Well, I used a reflection and a translation. Those are both rigid motions. Yes, they are congruent because I used only rigid motions. Okay, so again, very similar to the previous two problems. This time you had to try going through each of these transformations. And again, if at all you use a dilation, no dice, they're not congruent. All right, let's move on to the next problem to just save ourselves some time. Okay, this problem says determine if the two figures below are congruent. Use the drop-down menus below to justify why. Which point on figure 2 corresponds to point M on figure 1? So they give us two quadrilaterals named with different points. We need to identify whether they are going to be congruent or not. So is there a way to map one onto the other without using a dilation? Well, to me, these two figures do look like the same shape, right? Um, and they look like the same size to me. So I think that there is going to be a way to map one on to the other. So again, I'm looking for the shape. Are they the same? And the size. And I'm going to go check, check. So I believe that they're going to be congruent. And again, it's because then you would use only rigid motions. So now which point corresponds to M? Well, M is here. It looks like T is that same point that M is on figure 2. So I will put in T. Let's see how I did. Yes, good work. And you can see here, look what they did. They did a rotation and a reflection. Now, I've actually tried to take those opportunities away from you because they're very difficult to see. But it is a possibility. All right, let's try another one of these. Okay, so same kind of problem. Use the drop-down menus to see if they're congruent. Which point on figure 2 corresponds to J on figure 1? Well, immediately, right, I look for this idea of being the same shape and the same size. Yes, they look the same shape, but no, they are not the same size. Figure 2 is obviously smaller, which means it's going to involve a dilation, a reduction. So down here, I can automatically say the two figures are not congruent because I would have to use non-rigid motions. So now, which point corresponds to J? Well, there's still a correspondence. So let's take a look here and see what we think. So J is right here. Now, if I look at this, I think that I would do a reflection across the x-axis, which means if I did that, J would go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So J prime or J would be here. I would be here. H is 12 up, so H would be 12 down here. Just doing this quickly so I can get through. And G is 12 up, so it'd be 12 down here. So this would be the reflected figure. So then it looks like I would just dilate now, right? And that means that J, which is now here, would correspond to U because they're in the same position in their figures. So I think it's going to be U. Get rid of my pieces and parts here. Let's try it out. Yes, very good. So despite them not being congruent, you still have corresponding parts. All right, last problem coming here. All right, so if you take a look at this problem, now it says use the drop-down menus to explain if the two figures below are congruent, similar, or neither. If the figures are similar, state the scale factor. So if I take a look here, are they going to be congruent? Well, are they the same shape and the same size? Same shape. Yes, they have this like flag look, so I believe they're the same shape. Same shape. Same size? No way. This top blue one is a lot smaller than the green one. So they, to me, are going to be similar. So down here, my answers. Figure FGHI is not congruent to RSTU because rigid motions cannot map it. But they are going to be similar because using a dilation and some rigid motions can. So now what's the scale factor? Well, we just look at a pair of corresponding uh, sides. Now, again, order matters. It's going from F, G, H, I to R, S to U. It's going from small to big. This is an enlargement. Enlargement. That means your scale factor better be bigger than 1. So think about that. Scale factor bigger than 1. So I'm going to look at these two pair of vertical sides. So I to F is 2. F to R is 1, 2, 3, 4, 5, 6. So I'll take the larger divided by the smaller, and there's my scale factor of 3. That green one is 3 times as big as the small ones. 3. Submit my answer. Nice. All right, let's do one more of these, and that'll be the last problem in this group. Okay, last problem here again says use the drop down to explain if they're congruent, similar, or neither. Okay, so again, I'm looking over here at shape. So do these two things look like they're the same shape? And the problem I have is right here, right? This kind of juts in. It has like a sharp corner to it. This one is, we're going to call this convex. This one down here is called concave. And again, we didn't talk about this, but it doesn't matter because it juts in a little bit, I think. This one here is more convex. It's more rounded. It's more open. So they are not the same shape. So they are neither congruent nor are they similar. Despite the size or anything, they're just not either. Okay, so we'll come down here. So no, not congruent because I cannot map it. And no, not similar because I cannot map it. And it happens. What are you going to do? All right, great. So thanks for watching this video. If you have any questions at all, let me know. It is a long assignment. I get it. But again, hopefully you catch on and are able to do them quickly. All right. Thanks for watching.